This is the Centrifan PE Personal Evaporator. What it does is evaporate any solvents that you put inside using self-generating blowdown gas. There is no external vacuum source required, no vacuum pump, and all the maintenance headaches that go with it. There's no external source of blowdown gas, for example, dry nitrogen. However, fan blades in the circumference of the rotor as it spins generates a gas flow that, because of the geometry of the internals here, is driven into the vials to evaporate across the surface of the liquid to cause evaporation. The vapor is then generated inside the enclosure, and a portion of that gas flow is sent across to this condenser so that the vapor is extracted from the gas flow. It condenses on the surfaces of this cold trap, drips down, and is isolated and collected in this round bottom flask. The cold source for the cold trap in this case is a frozen water bottle. That's literally all the technology you need to generate sufficient cold to condense water vapor. If you had something much more volatile, ethyl acetate for example, dry ice and ethanol would do a much better job of extracting that very volatile liquid from the gas flow as it passed through the cold trap. In certain cases, you might even want to put a bath under the round bottom to prevent highly volatile materials such as that from evaporating again and getting back into the gas flow, essentially retarding the rate of evaporation that you can achieve with the Centrifan PE. The Centrifan PE has a heater built into the enclosure to warm the gas flow that's recirculating through the solvent containers. This not only speeds the rate of evaporation, it replaces the heat loss due to evaporation. Otherwise the sample containers would cool. There is a temperature control on the front panel here. This can go to a maximum of 55 degrees. Lowest point obviously is ambient. For example, if you had some work you wanted to do at 5 degrees, you could take the whole Centrifan PE, put it in a cold room, and set the temperature control to 5 degrees. Just wanted to show how the internals of the Centrifan come apart using no tools. And this would be for cleaning convenience. This is a spinning fan, stops as soon as you open the lid. The splitter is removed just by walking turning the rotor as you walk the extraction around, taking the tabs out of the vial mouths. The whole rotor can be lifted with the glassware in place by removing the retaining screw, lifting the rotor out. The fan is held in place by a nut on the drive shaft. It's a Delrin part. It has two wings on it, makes it easy to turn, and then the fan lifts right out. And now you've got simply the spinning drive shaft and this whole container. As you can see, I'm moving it here. If I remove the two fittings connected to the cold trap in the back, this stainless liner literally lifts out of the enclosure, and this can be put in a dishwasher, for example, if you wanted to clean up something which spilled inside. Reassembly is just reverse the process. Put the fan in place, add the nut, just snug it up, hold the fan, just keep it firm, turn the nut, reinstall the rotor, turn the fan to lock it in place. There's actually a place as you turn the drive shaft and the fan, this will seat itself so that the rotor remains locked to the fan as it turns. Add the retaining nut. This is now a secure single assembly here. Replace the splitter on the vial inlets. This enhances the evaporation rate by separating the inlet and outlet gas flows on the vials. So as this spins, You have the gas flow coming off the heater on the lid here, into the center of the splitter, into the vials, across the liquid, basically drawn out of the vials by the partial vacuum on the internal of the fan. Closing the lid, restarts the Centrifan. So this is completely disassembled right down to a cleaning step and reassembled in just a matter of a couple of minutes. No tools required. There is a version of the Centrifan which includes an optional timer, which is located on the panel in this position. This allows you to set an off time so that you don't have to run the samples to complete dryness, or if you're setting up some vials to dry over the weekend, obviously they're going to be dry in a few hours, and no sense having the just wasting the energy from the Centrifan running all weekend. So you can shut it off after 3 or 4 hours. The vials remain dry in a sealed environment, and the Centrifan will not be running. Another capability of the Centrifan is the ability to backfill the enclosure with a gas different than the air which is captured when the lid is closed. That's accomplished by connecting 2 pieces of tubing where this jumper is now connected. This is a barbed fitting here. It is at the outlet of the Centrifan enclosure itself. By connecting this to a source of nitrogen and connecting the other fitting here to a hood, you can basically displace the oxygen inside the Centrifan, the whole enclosure here, with the dry nitrogen. The high rate of evaporation is still supported by the fan. You'll be basically using the dry nitrogen, recycling the dry nitrogen through the cold trap back into the enclosure. This is just a bleed level of nitrogen which should be feeding the device to displace any oxygen inside the Centrifan enclosure. But this is the whole evaporation device. No vacuum pump, no external source of blowdown gas, completely self-contained. And again, the evaporation happens within this enclosure. There's a heater and gas flow is generated here. Because of the location of these 2 fittings, we're basically able to tap off about 10% of the gas flow, drive it through the cold trap, and return it. So it's a completely sealed system. You're collecting virtually 100% of what you evaporate. Thank you very much again for listening to this explanation of the Centrifan PE. If you have any other questions or would like a quotation, want to talk about having one of these devices in your own lab, please contact Modular SFC using any of the contact information on the screen. Thank you very much.